Now, considering the LHS, what you just have to do here is that we let log x is equals to minus y, and after that, here we can see that our x is equals to exponential minus y. If that is the case, the x, if you differentiate this, we have the x is equals to minus exponential minus y dy. And if that is the case, substitute from here. This integral of 0 to 1 x raised to power n log x raised to power n dx will now become integral of infinity to 0. Because why is it infinity? Because if you put 0 there, log 0 will give you infinity, and log 1 will give you 0. X, instead of writing x, this will be your x, be exponential minus y raised to power m log x, which is minus y, dot minus y raised to power n dot dx, which is dx, minus exponential minus y dy. From here now, we can say that minus 1 raised to power n, bringing this out. Now, if we interchange this, it should be from 0 to infinity. So this will definitely affect this negative sign. And we have exponential minus ym dot y raised to power n dot exponential minus y dy. Exponential minus y and exponential minus y. We have minus 1 raised to power n integral with 0 to infinity exponential minus y into m plus 1, since their base are equal, dot y raised to power n. And if that is the case, we say that let's put z to be y into m plus 1. Making y substitute the formula, we have y is equals to z over m plus 1. And if we do this, we differentiate this, we have the y will give us the z over m plus 1. Now substitute here. We have minus 1 raised to power n integral of 0 to infinity exponential minus z. Since we said that let our z to be this, dot what is our y? Our y is z raised over m plus 1 raised to power n, yes, dot y raised to power n dy. And what is our dy? Our dy is dz over m plus 1. And if that is the case, we have minus 1 raised to power n integral of 0 to infinity exponential minus z dot z raised to power n over m plus 1 raised to power n dot dz raised to power over m plus 1 rather. And if that is the case, this m plus 1 raised to power n, this is m plus 1. So we can say that we have minus 1 raised to power n over, bringing this together now, we have m plus 1 raised to power n plus 1 integral of 0 to infinity exponential minus z dot z raised to power n dot dz. And this we can write this as minus 1 raised to power n over m plus 1 raised to power n plus 1 integral of 0 to infinity exponential minus z dot z n plus 1 minus 1 dz. This z raised to power n plus 1 minus 1 is still the same thing as z raised to power n. So now let's consider, we are considering only this side. So now we have minus 1 raised to power n over n plus 1 over raised to power n plus 1 integral of 0 to infinity exponential minus z dot zn plus 1 dz. And recall that gamma of n plus 1 will give you 0 to infinity exponential minus z dot z raised to power n plus 1 dz. Therefore, minus 1 raised to power n over m plus 1 raised to power n plus 1 will give you n plus 1 will be the same thing as, multiply it with this, we have n plus 1. And n plus 1, this gamma of n plus 1, also recall that gamma of n plus 1 is the same thing as n factorial. Gamma of n plus 1 is the same thing as n factorial. So if that is the case, automatically we have minus 1 raised to power n over m plus 1 raised to power n plus 1 n factorial, which equals to RHS, our right hand side. Proved. Thank you.